Here's the solution for day 4, problem 1. Solve this equation. Well, what format do we have? Our equation has fractions, and we've encountered that before in an earlier chapter. The technique is to multiply all members by the LCD. The LCD is going to have in it an a minus 1 factor and an a plus 1 factor. So let's times our first numerator by that LCD. A minus 1 times a plus 1. Also times that next numerator by a minus 1 times a plus 1. And times the 3 by a minus 1 times a plus 1. Why do you do that? It's so that our denominators cancel away. A minus 1 cancels a minus 1. Over here, a plus 1 cancels a plus 1. Our first term becomes 2 times a plus 1. Our second term becomes 1 times a minus 1. And on the right side, we have 3 times a squared minus 1. To get a squared minus 1, I did FOIL on this times this. Next up, distributive property. 2a plus 2 plus 1a minus 1 equals 3a squared minus 3. Next up, because this is a quadratic equation, let's get standard form by getting a 0 on the right side. So subtract the 3a squared and add the 3. We will have negative 3a squared plus 3a plus 4 is equal to 0. To solve this quadratic equation, we could use the quadratic formula. But when I do the quadratic formula, I prefer the leading coefficient to be positive. So let's divide all terms by negative 1, making 3a squared minus 3a minus 4 is equal to 0. Now we can use the quadratic equation. The opposite of b is a regular 3. In the radical, b squared is 9. The leading coefficient is 3. And the constant term is negative 4. This is all divided by 2 times the leading coefficient, which is going to get us a 6. Now let's simplify in the radical. Take a calculator and type in this entire expression that's under the square root. It makes 57. At this point, we might wonder if the square root of 57 can be simplified. 57 can be factored as 3 times 19, but both 3 and 19 are prime numbers. So we won't be able to take the square root of either of those. We might as well leave it as the square root of 57. Now, day 4, problem 2. Solve this equation, but it does not tell us how to do it. So we could try factoring, completing the square, quadratic formula, or with graphs. I'm going to use the quadratic formula. The value of a is 5, the value of b is 1, and the value of c is 1. So x equals negative 1 plus or minus, b squared is going to make 1, a is 5, and c is 1. This is all divided by 2 times a, so that's going to make a 10 down there. Now we have negative 1 plus or minus the square root, and inside the square root, it ends up making negative 19. And that's all over 10. At this point, we see that we've encountered a problem. We cannot find a real number answer for the square root of negative 19. So if we're only allowed to use real numbers as our domain, we have to say empty set. In a future chapter, we're going to investigate what are called imaginary numbers, and at that point in time, we will be able to find some solutions to this equation.